My name is Kyle Smith, and I am a proud member of the distinguished engineering community at Capital One. And today I wanted to talk with you about chaos engineering and how at Capital One we are using chaos engineering to improve our overall resiliency posture. So one of the core concepts of cloud computing, I don't think he gave me the... So one of the core concepts of cloud computing is that failures happen. And you're supposed to architect for failure. And so when I say that failures happen, don't panic, be prepared, it's meaning that you can prepare for outages. You can prepare for things that you're not necessarily expecting to happen. But when they do, performing things like chaos engineering will help inform your decisions when you're troubleshooting and understanding how you want your application to behave. So today, what we're going to kind of focus on is why and how Capital One uses chaos engineering, the key components of our chaos engineering practice, our chaos experiment framework, and experiment objectives and common failure scenarios that we often see. So for those of you who are not that familiar with chaos engineering, I'll just real quickly state that chaos engineering is the art of injecting one or more failures to a system and identifying if the system can gracefully react to the failure that you injected. And so when we look at why Capital One uses chaos engineering, we use it in general to improve the resiliency postures of our applications. But what we do to do that is we look for hidden vulnerabilities. We look to validate that the applications can meet the resiliency requirements that have been set out by our architecture organization. We use it to test our failover mechanisms. Do our failover mechanisms identify certain failure modes, and do they respond properly to them? We use them to identify if application teams are properly configured to observe and be notified based on the different failure scenarios. So chaos really has provided us with a way to prepare for all the different outages or partial gray disruptions that we may face. When we talk about how Capital One actually performs chaos, we have 4 different types of events. We have a regional testing event that happens multiple times a year. It's a planned event, and application teams have to participate in at least 2. So this is a planned event. Teams know when it's happening. We have game day events, and the game day events are more on a monthly basis, and they are too also planned, but they're a smaller group of application teams that participate, and they're usually going towards a certain prove out a certain resiliency objective in each game day session. The third type is what we refer to as self-service. So this is where our application teams can use our chaos tooling on their own to validate various things like calibrating their alert thresholds. And then fourthly, what has been emerging is what we call a no-notice event. And this is an event where our PRE team goes in and implements a chaos failure without the team knowing or being able to prepare for it, and then observing if the team can meet the architectural or resiliency requirements. Okay, so I'm going to talk a little bit now about sort of some of the key components in our chaos practice. Really, the backbone here is the chaos experiment. the chaos experiment is really what drives all of this, and I'm going to get into that a little bit more in a moment. Underlying that experiment is the experiment designer. This is the set of capabilities that allow you to design what failures are going to occur, to orchestrate them, and create what I would call a predefined set of experiments. At Capital One, this is sort of reserved set of capabilities for more like the chaos SMEs that use these to then develop experiments that we put into a catalog, and the catalog is what's made available across the organization. And I'm going to get into the framework of our catalog in a moment. But the next key component is the fault injection engine. AWS has their fault injection simulator. You've heard of Gremlin, SteadyBit. There are a lot of organizations out there that have fault injection engines. And the key thing that the fault injection engine does in addition to injecting the failure is control, be able to stop it if something's out of control. So the job of the fault injection engine is really to mitigate risk when you're running these things in production. Testing results assessment. So one of the big takeaways that I have here is don't assume that people are chaos experts. Developers are chaos experts. Most of the time, developers and chaos aren't necessarily one and the same. And so it's very important for the people who are providing these sets of capabilities that you provide what success looks like. And so being able to assess and automate those results is going to just increase your adoption of your program because people will get very useful information out of their testing. And then finally, the chaos playbook. So this is how do we perform chaos. Sometimes tests we have to capture steady state. Sometimes the tests are pretty instantaneous. In some of our tests, they're weeks long where we want to see our applications run in a certain region over a period of time. Okay, so a huge key here to making chaos valuable to the enterprise. When you define an experiment, a lot of times people take the fault that you're injecting and they use that as sort of the driver. And it's really not. It's really the resiliency objective that you're looking at. That's the part that you should really key in on. And the fault that you use to inject should just support that objective. And desired outcomes. Because you are being very specific about what fault you're injecting, you should have a strong understanding of what success looks like. You should know what metrics teams should be looking at. You should know how does a team observe this failure? What alert should they be receiving? And so when you do an objective-driven, when you take an objective-driven approach, you start to look at objectives like, how long would it take me to fail over or to promote a read replica when I have a regional failure with RDS, right? How do I configure my alerts so that when there's network latency, but it's only in one AZ, I don't necessarily have to fail over between regions. I can just add capacity in those AZs that are healthy. And so we have tests that specifically look for those capabilities within our applications. Testing out scaling policies. Can the application withstand 120% of peak traffic so that if there are spikes and you lose an AZ, can the additional capacity in the other two AZs handle all of that? So taking an approach where you identify the objective first and then the failure is sort of a key to success. So at Capital One, when we develop our our experiments, what we've done is really gone and looked at what happens in our environment and then done our best to simulate those things. Now, when we simulate them, we're either calling the AWS APIs to make configuration or state changes, or we're using an agent-based script that with, for example, SSM, where it's going to run something locally. And really what the types of failures that we really look at are resource failures, right? That's a very common thing at AWS. Resource exhaustion, CPU utilization spikes, memory I/O exhaustion, network outages, and then the more difficult thing to deal with is really network degradation. So the network's up, but there's intermittent problems, right? And how does your application handle those intermittent issues? Because in most cases, health checks are not necessarily going to identify it as unhealthy because it's intermittent. We look at things like configuration errors, AWS's quota ceilings, API throttling. These are all the types of things that largely we're testing for. So, when you kind of step back and you look at it, there's about 5 different key session takeaways here. The first is, minimize the need for the developers to be chaos me's. That's a huge, huge part of making chaos successful and getting adoption. When you assume that people are chaos me's, the developers don't get as much out of the experience because they don't necessarily know how that failure is going to show itself or what does good look like for responding to that failure. Focus on simulating real-world failure scenarios. So use your own incidents. Look at AWS's set of health incidents and their root cause analysis. And you can see right there what incidents are common. You want to, as I mentioned, focus on the objective, not on the failure, right? So clearly, and crisp and clear definition, what is it you're trying to achieve with this experiment? And then what metrics matter? And what does success in those metrics look like? And then provide actionable results, right? So people don't do this just for the act of taking the test. Chaos and failure injection tools should be used to help configure your application so that they respond gracefully, but not only just due to any sort of standard or requirement. And then integrate your chaos testing earlier on into application development. So the same way application teams use performance testing, resiliency testing is just sort of another tool and another form of testing. And integrating it earlier on will enable you to not, to fail and not panic, and everything will be okay. So that's my session. Does anybody have any questions?